Hi, today we're going to be working with similar figures as part of our unit on rate, ratio, and proportion. We're going to determine whether figures are similar and find the missing dimensions in similar figures. In order to do so, we need to understand some of the vocabulary, including what similar means, what corresponding sides are, and corresponding angles. Before we will launch into today's lesson, let's do a little review on how to solve proportions using cross products. Take a moment now, pause the video, solve the proportions, and come back when you're done to check the work. Okay, welcome back. Let's check. Number 1, b equals 10. Number 2, y equals 8. Number 3, p equals 3. And in number 4, m equals 52. Well done. Don't forget, because this is an equal sign, we're not multiplication. We do not multiply across from 3 to b. We multiply by diagonally multiplying because cross products are equal. All right, to understand what similar means, it means that figures have the same shape but not necessarily the same size. So for example, every circle has the same shape. Based on its radius, the size might be different, but they are similar. When you have two figures and they're in the same general position, they have what's called corresponding sides, meaning even if you rotate the figure, the pieces go together, like the long side of a rectangle goes with the long side of another rectangle. Corresponding angles are also in the same general position. The two figures are similar if the lengths of the corresponding sides are proportional and the corresponding angles have equal measures, or they're congruent. So the angles have to be exactly the same and the sides just have to be in proportion. So for example, in this set of triangles, angle A, although it's at the top, is corresponding with angle E on the triangle that's to the bottom right. They both have a right angle, C and G, and angle B corresponds to angle F. So even though the figure is rotated, these two shapes are similar. So when we're identifying similar figures, we have to understand, first of all, what makes them similar. Well, they're all rectangles. They all have 90-degree angles, so all of those functions are true, so they can possibly be similar rectangles. But the last thing we need to find out is, are their side lengths in proportion? So we have to see that. And we're going to check that out here. If we look at 10 and 4 in this J rectangle, so the length of J and the width of J, and we compare that to the 5 and 2 of rectangle K, the 5 and 2, and we use cross products, 20 does equal 20. So rectangle J is similar to rectangle K, and this little sideways S that I've highlighted is the idea that J and K are similar. Now if I look at J and L on the other hand, again my 10 and my 4 for the length and the width, then in L I've got 12 and 5. Those are not similar because 50 does not equal 48. So although they have the same angle measures, they don't have the same side ratios. So we're going to try and figure out here which ones are similar. So we are going to take the 8 and the 4, 8 feet and 4 feet from rectangle A, and 6 feet and 3 feet from rectangle B, and we're going to try and see if we set that up in proportion. In fact, those are equal. So trying the same thing with B and C, I'm going to have 6 over 3. Does that ratio compare equally to 5 over 2? And when you do cross products, you'll notice that it does not. 15 is not the same thing as 12. So we're going to try and do some for the real world problem solving. And here is a way to set it up for yourself. A picture is 10 inches tall, 14 inches wide. And we want to scale it to 1.5 inches tall for a web page. And that is something that people do all the time when they're scaling photos. So we're going to see that we have the width of the picture is 14 and the height of the picture is 10. The width of the web page is what we're trying to find out, and 1.5 is the height on the web page. So we're going to set up that proportion, and we're going to use cross products to solve, but since we are missing one of the measurements, We're not trying to see if they are proportional, we want to make them proportional. So we do that by using the cross product idea. So 14 times 1.5 gives you 21, and then we multiply the 10 and the w. But we're going to have to divide both sides by 10 to find out the width is 2.1. And again, when we write our answer, we want to make sure that we do include our units. It's 2.1 inches wide. So let's have you try this now. Here's a painting, 40 inches long and 56 inches wide, and we want to scale it to 10 inches long to be displayed on a poster. So we have to figure out what the width of the painting should be so that the two shapes are similar. Well, one thing you can do is set up a little ratio board for yourself. So if you notice, I have a little table here. It's got the length and the width. Here is my original painting, the 40 and the 56, and here's what I want it to be scaled as. If you use a ratio box like this, it's very easy to set up the actual math work because now I practically have two fractions sitting right next to each other. And I can say, well, 40 over 56 is equal to 10 over what? And I'm going to set that up and again use the cross products. Again, see, I've got the 40 over 56. This is the length and the width of the original. The length of my new one, the width of my new one that I don't know. Using cross products, 40 times W equals 560. I want to divide both sides by 40, and I will determine that the width of my new picture has to be 14 inches. So let's have you try this one. A t-shirt design includes an isosceles triangle with side lengths 4.5 inches, 4.5 inches, and 6 inches. And an advertisement shows an enlarged version of the triangle with two sides that are 3 feet long. What's the length of the third side of the triangle? So don't get too worried that there are 3 measurements, because if you notice in an isosceles triangle, the two side lengths are the same. So that means the two similar side lengths, the two identical side lengths are the 3 feet long ones. So we really only need to use 2 measures, the 4.5 inches and the 6 inches. We're going to use the 3 feet in comparison to the 4.5 feet. So when we set up that ratio box, again, here's my original triangle. The isosceles sides are 4.5 inches long, and the third side is 6 inches. Here I have 3 feet for the isosceles side, and I'm trying to figure out the third side. And it's the same idea. I can use this fraction, or this ratio, and make it proportional to this ratio. Even though we have inches and feet, the idea of proportion in this case is that the 4.5 inches is the same as 3 feet. So I want to make sure that I put this together. Let's see how you do. Well done. If I have 4.5 over 6, that equals the 3 over W. Again, cross products are equal. 18 equals 4.5 times W. I divide both sides by 4.5, and 4 is the width, so the width would be 4 feet long. Try this one, which is very much the same, that has a flag in the shape of an isosceles triangle. The two sides that are identical are the 18 feet, and 24 feet is the one other side. And we want to make a smaller one that's 4 inches for the two isosceles sides, and we're trying to figure out the third side. So the ratio table looks like this. 18 and 24 compares with 4 and something we don't know. And we're going to do the same idea. So 18 over 24 equals 4 over W. In this case, when we divide, we do get a fractional answer, but that's okay. It's 5 1/3 inches long. So take a moment to use the properties of similar figures to answer these 3 questions. Make sure you put them in your notebook, and we will check these in class. Have a great day.